Hi, it's Mr. Fletcher here. We're going to be looking at a simple probability tree diagram now. We've got Rebecca and she's got 9 coloured beads in a bag, and 4 of the beads are black and the rest are green. Okay, so we've got 4 of these beads and they are black and the rest of them are green. Okay, and we know we've got 9 of them. Now she removes a bead at random from the bag and she notes the colour of the bead before replacing it. Now that's a bit of a key piece of vocabulary there. That's what really makes this tree diagram simple, is that she's putting that bead back in. So as we move along the tree diagram with our different choices, then the probabilities don't really change because we've always got the same number of beads. So she chooses one bead, she replaces it, and then she chooses a second bead. So the first thing we've got to do is draw the tree diagram showing all the possible outcomes. So I've started you off down here. So we've got a first choice and we've got a second choice of bead. And we've got all our tree diagram branches there, and we know where we're going to put our probability fractions. So the first one then, so we've got a black bead. So what's the chance of getting a black bead? Well, there's 4 black beads out of 9. So 4 out of 9 are black. Now, if the rest of them are green, then 5 of them must be green. Okay, there's 5 out of 9. Now we come to our second choice of bead after we've put the first one back in. So there are still 9 beads in the bag. So what's the chance that it's black? Well, there were 4 beads to start with that were black. There's still 4 beads. And we look at this one, there must still be 4 beads that are black. And for the green ones, we started off with 5. There must still be 5 because we've put it back. So we've drawn the probability tree diagram. So now we've got some number work to have a think about. So we're asked to calculate the probabilities that Rebecca chooses, first of all, 2 green beads. So 1 green bead, 2 green beads, we're down here, right? Now when we go along the branches, we are multiplying. So I need to do 5 over 9 times 5 over 9. We do not need, in probability, to be doing any simplifying of fractions. So we're going to have 25 over 81. So that's our answer for that one. So now we want a black bead followed by a green bead. So a black bead followed by a green bead. That's going to be 4/9 times 5/9. So that's going to be 20 over 81. Okay. Now it gets slightly more involved, so now we need to have at least 1 green bead. So there's 2 different ways we can go, right? I can go black and then green, I've got 1 green bead, or I could go green and then black, and that would give me 1 green bead. So that would be 5/9 times 4/9. Well, we know what that is. That's going to be another 20 over 81. So what we've got now is all the ways of getting at least 1 green bead. So if we're multiplying going along the branches, once we've got to the end of the branches and we're going up and down, we're adding them up. Okay, so at least 1 green bead would be 20 over 81, add 20 over 81, add 25 over 81, which is 65 over 81. Now, not 2 green beads is going to be everything that's not the 2 green beads. So it's going to be this one, and this one. So herein lies a bit of a trick. So I could calculate the probability of black and black and then add up the three probabilities. Or I could say, well, I know that all the outcomes are going to add to 1. So if I want all the things that are not this bit at the bottom, why don't I just take the bit at the bottom away from 1? So that is going to be 1 take away 25 over 81, or I could write that as 81 over 81, take away 25 over 81. Then it may be a little bit simpler to think about the how to do the numerator subtraction. So we're going to end up with 56 over 81. Okay.